Hello, let's do the New York Times Hard Sudoku for November 5th, 2024. Just to let you know, there is a union strike at the New York Times right now, and they have requested us to not play their digital games. I figured since this has been imported into Sudoku Pad, you could still play this on Sudoku Pad without counting as a click-through. I don't know if that's where you draw the line or not, but I know people enjoy seeing the me solve this specific Sudoku every day. I do not get views on when I do random other Sudokus, so I did decide to play this. I hope that's all right. So let's get started. Right, there is in the link in the description will go straight to Sudoku Pad, so you will not be loading up the New York Times website. All right, I'm going to get started right now. All right, I'm immediately seeing this 7 and this 7. Looking into this box, putting a 7 in one of these two cells, it's crossing on this 3, 5. These 7s point in along with this 7. This 7 looks up, placing the 7 in this box. We can follow up more with 7s, into this box, putting a 7 in one of these two cells. We also have the 8 looking in. Let's see, 5 and 2. See, we do have two 8s looking in. So there's an 8 in one of these 3. Let's see, anything else up here of note? I don't think so. All right, let's move on to the next band. I'm seeing 3, 5, 9 right away that need to be in this row. Unfortunately, there are 4 places for it, but that means that these 3 digits are going to be quite restricted because they're not going to be the 3, 5, 9 and they're not the 4, 6. So let's just think about what they could be. They could be the 1, 2, 7, 8. 1, 2, 7, 8. And these can't be 7, 8. So this is 1, 2 only. This is not 7, so this is 1, 2, 8. This one's not 8, so it's 1, 2, 7. Oh no, sorry, that's not in the same box. Whoops. I wasn't doing the row, I was doing these 3 only. Okay, so that's all we get out of that. Any buddies? We have the 6. Yeah, we do have 2 6s. That actually places the 6 in here. These 6s look up, putting a 6 in one of these 3. We do have 2 5s as well. This 5 looks up, putting a 5 in one of these 2. Okay, so 3 and 9, 5, 6. All right, that's all the buddies. I think that's all I'm seeing. Let's just move on to the next band. So 2 does not have a buddy. We've got 1, 3, 5, 7. So only the 7 matches. The 7 looks down. That tells me that there might be some cells that see a whole lot of these digits. These 2, for example, see the 1, 3, 5, 7, and 6. So what can be here? They can be the 2, 4, 8, 9. Is that right? 2, 4, 8, 9. This can't be 8, 9. So this is 2, 4 only. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. This is all of 2, 4, 8, 9. We're not going to mark that. This digit sees the 1, 3, 5, 7, 2, 9. So it's down to 4, 6 only. Sees 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. I'm going to think about this. I just need to know what's missing from this box. We need the 1, 2, 3, and 1, 2, 3, 5, 8. So the 8 does look down here, putting an 8 in one of these 2. That points up, removing 8 from this cell. So first of all, these 8s look in, putting an 8 in one of these 2. But also, this is now a 1, 2 pair for both the row and the box. So the box has 3 digits remaining that aren't 1, 2. It's the 4, 8, 4, 7, 8. And I'm seeing that this can't be 7 or 8 and because of the pointing 8s. And so this has to be the 4. And then we're left with a 7, 8 pair here. When I mark that, I did notice these 7s line up, but we already have a 7 in this row, so it's not that doesn't do anything. But this 7, 8 pair does mean there's 3 digits left in this column. We need the 1, 2, and 3. So we can just mark that. That's 1, 2, 3 triple. So 4 digits left in this box. We need the 4, 5, 6, 9. This is not 5 or 9. Or 4. This isn't 4, 5, or 9. So this is a naked 6. And the 4 looks up, placing the 4 in this box. And so now we just need 5, 9 here. Nice. We have the 5, 9, and then this is 1, 2, 8. We see this 1, 2 here. Cleans it up a little bit. And then here we need the 1, 2, 3, and 5. Okay, they all clean up a little bit. This isn't 2, 3, that's not 1, that's not 5. Okay. I think this stack did pretty well. Wasn't even there yet, but kind of skipped ahead a bit. Very nice. We got this 4 and 6. Let's make sure we followed up properly and all that. This row is down to 3 digits. We need 1, 2, and... I missed it. 1, 2, and 4. I mean, this sees 1, this sees 2. Oh, that's all we get. 6 to 7. Would like this to do more, but I don't think it does at the moment. Okay, back to this band. Did I miss anything here? I don't think so. You have this 1, 3, 5 that needs to go in these 4 cells. This can't be 3 or 5. Oh, if it couldn't be 1, we'd be off to the races. But oh wait, it's 1, 3, 5, 7. Yeah, there we go. So we need 1, 3, 5, and 7 in this column still. We have 8, 9. So if you want to think about it this way, if you prefer, this is a naked triple. If we were to pencil this, it would be 2, 6. But you can see that these 4 cells are the only 4 cells in the column that can accommodate the 1, 3, 5, and 7. Because they're in this box, they can't be in this column. So this ends up 1, 3, 5, 7. So we can just pencil in 1, 3, 5, 7 and clean it up a little bit. This can't be the 1 or the 7. This can't be 3, 5, or 7, so it's a naked 1. And then we're left with this 3, 5, 7 triple, and then this is going to be the 2 and the 6, because it can't be 4. So now this is a pair as well, because it can't be 1, 2, 3, 4, 5, 6, 7. It has to be 8, 9. Yeah, this 8, 9 looking down did put 8, 9 here. That's probably the easiest thing to see, and I saw it last, which is just great. Anyway, this row has been reduced to 4 digits because I placed this 1. So we need the... In fact, we have this 1, 2 pair here, and then this 1 looks in. So the 1's in one of these 2. Let's mark that. But yeah, this row needs 2, 4, 8, 9. Well, the 4 is not here, which means the 4 is over here. That's going to claim the box. These can't be 4. I guess they couldn't be 4 anyway. We have the 2 4s. What was it? 2, 4, 8, 9? So these are 2, 8, 9. These are all of them. All right. Take a step back. What was I doing? I was doing this stack, I think. So this 3 does look in here. This 3 looks in. It puts a 3 in one of these 2. It's something. See, I've got 8 and 9. I feel like, yeah, there's 3 places for 8 and 9. These are going to be restricted for sure. They're not 1. They could be 2, 3. Oh, they can't be 3. There's 3 in the column, right? Can't be 3. The bottom one could be 4. There's this 4 here. They could be 5. They can't be 6, 7, 8, or 9. So we're down to 2, 4, 5 here. Can't really do anything with that at the moment. I'm going to look at this last stack real quick, and then we'll take a closer look at everything. These 5s look down, putting a 5 in one of these 2. Oops, meant to corner mark that. We have this 5 as well. So we have these 2 5s, the 3. 3, 5, 4, 6, 7. Okay. I'm not sure there's more to see here. So, what did I miss? I need... I was going to say, this 5, 6 probably reduces this cell. So, we need a 1. We have 2, 3. We need 4. We have 5, 6, 7, and we need 8. What's kind of our low-hanging fruit here? Do I need to pay more attention to my boxes? We do have this 1, 2 pair. So this cell's not 1 or 2 in addition to its box. So it's not 1, 2, could be 3. It's not 4, 5, 6, 7, could be 8, 9. These 8, 9s are problematic. 2, 4, 6, 5, 7. I'm not seeing anything obvious to look at. Maybe this row. Less obvious, but we need 1, 2, 3, 7, 8. This is not 1 or 7, so this is 2, 3, 8. Neither of these are 7, so these are 1, 2, 3, 8. This one's not 3 either, so 1, 2, 8. A little desperate marking there. Oh, this is a 2, 4, 5 triple. I missed it. So there's a few things we can learn from this 2, 4, 5 triple. There's the obvious thing, but I want to show you the less obvious thing first, because noticing this before you like go off on a big tangent from the obvious stuff, you might forget to apply the interesting results, right? Well, all results are interesting, but this is sort of the less trivial result, which is we have this 2, 4, 5 triple, which means 2, 4, and 5 are going to end up in these 3 cells in some order, right? If they didn't, we wouldn't be able to fill all 3 cells. There's no other digit that can go in these 3 cells, only 2s, 4s, and 5s. So in some order, we're going to end with 2, 4, or 5. But we also already know that this one's not going to be the 5. There's already 5 in the row and the column. So if this one's not going to be the 5, that means the 5 is going to end up in one of these 2. So you know from just the triple, you don't even have to look at the results of the box and all this other stuff. You know from the results of the triple that 5 is going to end up in one of these 2 cells. And that means that's going to point down, and that's going to let us place the 5 and the 7 here. It's going to come back up, letting us place the 3. We could have also placed the 3 by removing the 2, 4, and 5 as options from this cell. And then this also finishes with a 6, last digit for the box. This 3 looks over, giving us the 2, 1, and 3. The 2 comes back. This 1 looks over, giving us the 4 and the 2, giving us the 5 and the 4, the 9 and the 5. This is 8 and 7, not 4. That's a 3 and a 4. That's not 8. So this is a 1, 2 pair. So that's good. Oh, what did I just do? I clicked the wrong thing. That's going to remove 2 from these as an option, giving an 8, 9 pair, which places the 3. Only placed for 3 in the box. So this is going to be an 8, 9 pair for the row, and that finishes this cell. It's a 2. I think we've cracked the puzzle. This is a triple. This is a triple. Let's just find out what they are. We need a 1, 2, and 7 here. This can't be the 2 or the 7, so this has to be the 1, leaving a 2, 7 pair. For this, we need a 6, 8, 9. Only thing I see is that 6. That's it. It's way too late in the puzzle to even worry about uniqueness, but I do want to point out that this is a unique rectangle, which forces this cell to be 6. Uniqueness techniques depend on knowing that there's only one solution to the puzzle. That's technically not a given in Sudoku. It's just highly encouraged, because otherwise you can't logically solve the puzzle. So in most published Sudokus, all the good ones, have only one solution. Otherwise you were forced to guess at some point. And there's more than one solution, so you might get a different solution than someone else. But anyway, so if you assume there's only one solution, which is a valid assumption in New York Times puzzles, I still don't make it though, then we know that this has to be 6, because if it wasn't 6, we'd end up with all these 8, 9 pairs here that could not get resolved at all. It would be impossible to resolve this 8, 9 pair. Because there's an 8, 9 pair in the column, there's an 8, 9 pair in this column, there's an 8, 9 pair in this row, 8, 9 pair in this row, 8, 9 pair in this box, 8, 9 pair in this box. And so there would be no 8 or 9 at all that would look into here telling us how to resolve the 8 and 9. So there'd be at least 2 solutions, with 8s here and 9s here, or with 9s here and 8s here. So as a result, we know that since there's only one solution, we know that this ends up being the 6 that we excluded. But we don't need to use that. We're at the end of the puzzle anyway. But I'm going to highlight this, and I'm going to corner a 6, and just to prove that does end up 6. 6, 8, 9 for this column. It's not a 6. Let's see. What's our easiest thing to do here? Maybe this vertical has more. Well, the 1 and the 4. We do have the 2 4s looking down. This 4 looks in. Okay, that's not enough to do anything with. 8, 9 pair here does mean we're down to 1, 2, 3, 4 here. So this is only 1, 2 because of the 3, 4 in the column. Oh, it's not even a 2 because of the box. So that's our 1, that's our 2, that's our 1. That is not a 1. We get our 7 and our 2 here. That's not a 7. That places the 7 here. 2, 6, 8, 9. Basically, where are 5 and what's the other digit? 3 and 5 in this row. Well, this 3 looks down. None of these are 3. So the 3 ends up here, and then this is the 5 for the row. This is 2. This is 8 and 1. That's 5. That's 1 and 2. That's 4, 6 and 2. That's 9 and 8. That's 9. That's 6. And here we go. We get the 8, the 9, and that does end up a 6. That's 8 and 9. That's 8 and 9. That's a 4. 3 and 8. That's 8. That's 3. So DT in the corner right at the end. This sort of had this ended up being an 8, 9 in the solution, one of them would have had to be given. So let me show you an example where you have that unique rectangle, but it's interrupted by a given, so it's allowed, like, because that given tells you which order it goes in. So it's usually pretty easy to find them. Just gotta find something. Sorry. 7, 4. Nope. 8, 1. Nope. 8, 5. Practically impossible to avoid these. We'll find one in a second. 9, 7. 9, 3. 1, 2. Here we go. Here's one. I'll just make it purple. We'll see rid of that. So the solution to this puzzle, the entire solution, has this unique rectangle in it. There's going to be a bunch more. They shouldn't be that hard to find. Here's another one in green. They both happen to be 1, 2s. They don't have to be 1, 2s. But anyway, you're going to be able to find a whole lot of these in here. There's always going to be at least one given, which tells you how to disambiguate them. So just thought I'd point that out. All right. So Ben, if you find a potential unique rectangle with no givens, then that means it's not 1, and you can do your best. You can make the logical deductions with the assumption that there's only one solution. You can make logical deductions about what digits are not possible and what digits must be in certain cells. All right, cool. Well, hope you enjoyed this, and if you did, why not leave a like, subscribe, and a kind comment below.